Hello. Today we're going to start talking about basic functions as we navigate through our SBAC review. And so I wanted to give you just a little summary of what you might expect to see when we talk about functions. It won't cover everything possible, but it'll give you a general overview of what's going on. So the first thing I would say about functions is that you have two types of variables with functions. You have an independent variable and you have a dependent variable. And so one thing that you see frequently when you're looking at functions is they have like what they would consider a function machine. And so in would go your independent variable. So a lot of times we call that the input. And the dependent variable comes out. So this is your output. And your dependent variable. This stems from when you have some sort of equation, and then there's some sort of function rule. We oftentimes think of as your formula. And so when we start talking about functions, we'll describe what basic formulas there could be that end up being there. As far as things that you're used to seeing, you have your x, comma y. This would be your independent. And so, and here's your dependent. Now, these are not the only ways that you begin to see that. The other way that's very, very common is function notation. Okay, so function notation. And what it does is it kind of really gives you this feel for a rule. So function notation, oftentimes you'll see f of x equals some formula based on x. Example, f of x equals 2x squared plus 7x minus 9. Okay, so that would be an example of function notation. We oftentimes see f of x, but that's not the only way you can see. You can see g of x. You could see h of p. You can see a lot of times population based on, say, time. And all of these are function notations. What you get with function notation is this ability to assign variables to describe exactly what you're working with. So like this one could be the population based on time. And hence they have the capital P and the lowercase t. And so it can become really, really descriptive. It does take a little bit of time to get used to the format of it, but once you're used to it, it's nice in that you have, again, these variables. Well, all of these act as your inputs, and you can see them inside the parentheses, just like you would see it input into the function machine. And so it just gives you this nice sense of input. It's inside, and it also reminds you to use the parentheses when you're substituting. Now this is just the same thing you've got to remember as your x and y. And so it's like this idea that this is always going to be your input or independent this is going to be your output or dependent variable. And again, you could see this in a different format where it was like x comma f of x, and all it's really commenting on is that the same x-y relationship, input output, happens. Okay, so you may want to pause. That's a lot of information so far. It hopefully jogged a bit of a memory about function notations, input output. Okay. The next thing they oftentimes ask us about is let's just say f of x a function. And what they mean by that is we do have certain rules surrounding functions. Like a soda machine or whatever you have. Whenever you push one of these buttons, your hope is that it outputs exactly what you're asking for. So if you wanted a Pepsi and you hit the Pepsi button, you better hope that the Pepsi comes out. Right? And so this analogy kind of helps us think about what is going on with our functions, and in that when you hit one input has to have exactly one output. Okay, and if you're hitting your soda machine and output comes a Sprite instead of a Pepsi, even though you hit the Pepsi button, that's not going to make you very happy. Our functions work the same way. So if I input a Pepsi button, then I need to get a Pepsi out. And so you can see this in a couple different ways. Like they'll list it out, a set, let's just say 1, 2, 2, 4, 3, 6. They close this off. This would be considered a function. One input has to have exactly one output. Boom. So this input has one output, this input has one output, this input has one output. A non-example would be something like 1 maps to 2, but 1 also maps to 6. And 2 can map to 4. And so the error in this is that the 1 maps to both 2 and 6. So it's like that soda machine where you could hit Pepsi, but it doesn't put Pepsi out, it outputs the Sprite. And so there's a lot of examples. Probably the number one example that bothers people is when you have the same input. So like 1 maps to 2, 2 maps to 2, 3 maps to 2, 4 maps to 2. And this bothers a lot of students because they see repeated 2's. But the 2 is as an output. So one input has to have exactly one output. The input had only one output. This input had only one output. This input had only one output. And so this is an example. All right. Down here, if we were to write something similar, but I had repeated x values, so 1 maps to 2, 1 maps to 3, 1 maps to 4, 1 maps to 5. If we were to write this out, it looked like this. 1 goes to 2, 3, 4, and 5. This input would have multiple outputs, would be not a function. Okay. All right, so what functions do we know about so far already from our experiences in math? So types of functions. You've seen the kind right there where they give you a set of coordinate points. But you also have ones if you've seen before. You have linears. So if I'm looking at a graph of this, there's a linear. General form, y equals mx plus b is slope-intercept. They generalize it even better in ax plus by equals c. This is what they call standard form. Okay. You've seen quadratics. So it's that U-shaped graph. Standard form for this is y equals ax squared plus bx plus c. There's vertex form, y minus k equals a times x minus h, quantity squared. That's one. You've seen cubics. And so y equals a x cubed plus bx squared plus cx plus d. You've seen, I'm just trying to think of all the ones we've done in our time here. Absolute value, where it's like two linears. So this would be y equals a x minus h quantity plus k, absolute value. You may see the inverses of some of these, so like square root function. You might be wondering, well, Mr. Heslop, why doesn't it have, if that's the inverse, why doesn't it have this down part? And here's a prime example of a function that we restrict based on it not meeting the criteria of a function. Because if I look at this input right here and I went and tried to figure out what its output would be, there would be two output, an output here and an output there. And so this is not a function if we have this black dotted line. It only is a function if you keep only the blue. Cubic works a little bit differently in that if I have a cube root, I can lay this down on its side. And it works just fine because I only have one input. And so what you might hear when you're researching this is the vertical line test. And so basically it's if you can draw a vertical line and it intersects the graph more than once at any time, if you draw a vertical line and it intersects the graph more than once, it is not a function. And so this would fail it because it hit here and here. But any line I drew vertically through this, it'd work out just fine. And that becomes really quite an important concept, but it's really based on the definition of a function where we have one input and one output. We won't get into the onto or one-to-one description, but basically identifying whether something's a function or not is really important. Other graphs. You have your rational. So rational. They're unique because they have gaps. They have what we call vertical asymptotes and horizontal asymptotes. So it looks kind of like this. And the last two that I'm going to look at for you are the exponential and the logarithmic. So the exponential goes through here, kind of goes up, should go through 1 unless there's some acting condition upon it, and then its inverse is logarithmic. And so again, just trying to give you a broad overview of functions, this input-output idea, refresh your memory on all the family of functions that we have, the types of functions that we've covered. There are more. You've got your sine, your cosine, your tangent functions. There are various polynomial functions. Again, you have your rational functions. Polynomial functions being so widespread, it's tough to give you a single one. And so polynomials, you could talk about odds and even functions. They're the broad heading for the quadratic and the cubics. And there's just a lot of information there. I don't want to overwhelm you. So here's your basic overview. Stop, pause, go research anything that you think is important or spurs some interest. And thank you for your time.